Hi everybody, and welcome back to the next video. So we're going to talk about the last operation that is commonly associated with functions, and it's called the composition of functions. But before we define the composition, let's return to a basic example we already know how to do. So we're going to let f of x equal the square root of x squared plus 1, and we're going to evaluate this at f of x, f at x, the expression x minus 1. So let's do that. So let me change the color here. Oops, not so thick. There we go. So f evaluated at x minus 1. Well, remember what I said before. Is everywhere you see x, you're going to replace that with the parentheses, and then the squared goes outside it if you have an exponent, and then we get the plus 1. So then, whatever inside the parentheses here will go inside the parentheses here, so x minus 1 as well. And then we'll simplify this. This is going to be equal to, well, let's multiply this out. This will be x squared minus 2x plus 1, and then this plus 1 is an additional plus 1 here, and this is rewritten as the square root of x squared minus 2x plus 2. So notice that we could have also done this. We could have let g of x, so be a second function, be x minus 1, since x minus 1 is just a line and all lines are functions. So notice then that f of x minus 1 is really f evaluated at the expression for g of x. And this is what's known as a composition of two functions. So a composition is when you take one function and evaluate it at the expression that defines another function. And so we have some special notation that handles composition of functions. So this is the definition. So let's blow this up a little so we see it clearer. So we have this little circle notation here that represents composition. So we have f circle g of x. So this is red circle, or composed with there's some other terminology, but I will typically say circle, but composed with is good as well. So f composed with g is just f evaluated at the expression for g of x. And notice that we can reverse the order as well, and we have g circle f of x, and that's going to be g evaluated at the expression for x. So one thing I want to note is just some of the notation here, because people have a sometimes hard time remembering which goes first, the f or the g. And notice that when I write f circle g of x, when you want to write the next step, you write all the symbols in the same order. F, G, and the x, and of course, and then the x always gets a parentheses around it, and then between the two letters you put a parentheses, and then you just have to close the parentheses after the x here again. And similarly, when you do g circle f of x, you just write all the letters in the same order. The x always gets its own parentheses. You put the other left parentheses between the two other letters, and then you always put an extra parentheses on the end. So this is a good little mnemonic device to remember how to write the notation here. So let's see an example of composition. So well, there we go, it's way down here. So we're going to let f of x equals the square root of 3x plus 1, and we're going to let g of x be x squared plus 2, so we're going to find both of these compositions. So we're going to start with the first one here, f circle g of x. So when you're always learning new notation, you should always write it down. So remember what I did before. I'm going to write the f, the g, and the x. The x gets its own parentheses, and then we get a parentheses around the g of x. So you put one between the f and the g and the one on the outside. And so now what we're going to do is we're going to take the expression for x squared plus 2, and we're going to put it in here for g of x. So this is going to equal f evaluated at x squared plus 2. And then this is just like our very first example. We go to f and write what f is. So f is this expression here. So we're going to write it in here. But again, just like before, anytime we have an x, though, we're going to replace it with a parenthesis. So we'll have 3 times the parentheses, and give yourself some room because you're going to write a whole expression in here, plus 1. And then we're going to take this expression, and since it's in the parentheses, and we're going to put it in all the parentheses. So in this case, x squared plus 1 goes in there, or plus 2, excuse me, goes in there. And then we just simplify it like we always do. So we're going to get equals to the square root of 3x squared from distributing to this term, plus 6 from distributing to this term, plus 1. This is going to be equal to 3x squared plus 7. And that is our answer. So now let's try it for our other function. So let me do a little erasing here because I do want to keep the problem on the... Oh, I can copy the problem, I guess. Let's see if I can grab that. One more time. There we go. We'll copy that and bring it along with us down here. And there we go. So here is our example again, but this time we are going to work with this function. So, again, we're going to write g circle f of x, and so we write the letters in order: g, f, and x. X gets its own parentheses. There's a parentheses between the g and the f, and you always put a extra one on the end. And then we're going to do the same thing we did before. Is we're going to take, now f of x is in the middle, so we're going to take this expression and plug it in for f of x. And so we are going to get that g is going to get evaluated at the square root of 3x plus 1. And again, this goes back to our first example in this video, is that we are going to now look at g and write it on the next line. But everywhere we have x, we are going to replace it with the parentheses. And then remember, exponents always go outside the parentheses, and then the plus 2 just comes along. And so we're going to take this expression here and put it into this parenthesis. So this is going to be the square root of 3x plus 1. Now, the square root and the square cancel out and give you 3x plus 1, and then this plus 2 just comes along for the right, and then we can combine like terms and get that 3x plus 3 is the answer. So let's summarize our results. So let's capture this and copy it and bring it down here and compare it. So this here, we have that g of f of x from this calculation right above is 3x plus 3, but f circle g of x is equal to, and let's paste in our what we copied. So erase that, bring this over. So f circle g of x equals the square root of 3x squared plus 7. So notice here, order matters. If you switch the order of f and g, most of the time Oh, it's a frowny face because it's not a desirable property. Most of the time you switch the order of G and F and you're going to get something completely different. There are times where you're not, and that's going to be a subject of a later video here. But for the most part, most functions, you switch the order, you get something different, so that's made your little spot, frowny face here. But that should give you the basics of composing two functions. So next thing we're going to talk about is if I just give you a function, can you find two functions that compose to make up that given function? Sounds complicated, but it really isn't. So that'll be the subject of our next video. See you then.